Okay, this is Simple SolidWorks. Once again, we're going to try to, on this lesson, we're going to try to go over the sheet metal features. Currently, I have a part here, but I'm going to start from the beginning so that you guys get to see how I did initially started this. So I'm just going to delete this and start all over again. So currently, we have nothing there. As you notice, there's hardly anything being activated. You got to delete that. And now you can see that most of this stuff has been grayed out. Because in reality, when you start a sheet metal, you can only do a base flange or a loft bend, right? Or a sweep flange. These things that are sort of active is the things that you could do. But today we're just going to go over the base flange and go over as far as, selecting the type of tables that you can work with if you have that all preset, or if you don't have a preset, where you could actually go to get these things set up so that you could quickly create, a sheet metal part that meets the standards of your company. So let's get started on this. So we'll start off first with a base flange, which is what I'd like to always start with. It's going to ask you where you want to place it at. You say, let's say the top plane of this. And basically what you're going to do is you're going to create a sketch. So if you come here and you say, look at the sketch, now you have your point of origin facing the right way. And you click on that spot and you come over here. And then you want to sort of create, some dimensions. Just give us a dimension there so that you got exactly what you might need. And sort of you have it, you're going to start off with a box. Let's say the box is going to be 12 by 16. Now, once you confirm that and you confirm your sketch, it's going to then activate that command, the base flange command right here, right? So here is where you could pretty much pick to see what gauge you want to use. So for instance, if you don't have your gauge table set up, you don't have to click on that. But in that point, that means that you would have to pretty much know all of these parameters here by memory. Like you got to keep that stuff in your head, right? Or you could set up a gauge table already set up and sort of have that table pretty much as an option that you could select. In our case, we have these gauge tables selected and made, and they're all of this is an Excel file, and I'm going to be opening that up in a minute, or maybe in another lesson. It takes a while to open that up, and you can see that you have already here the type of gauges that this particular table here has already pre-set up. So this table here has only 3 types of gauges, right? This company only uses 14, 16, and 14 gauge. So if you want to use the 14 gauge, you see how that changes here? If you use the 16 gauge, it changes it here. If you use the 18 gauge, it changes it there. So this changes the thickness already preset already for you. And it has all of these variables sort of preset as well. Now you could change that. I don't mean you have to keep it that way. You can say, well, I want to use a K factor, right? If that's your company standard, or if you want to use the bend allowance, if that's your company standard, you can say my bend allowance is like 0.0625, right? Something like that. Or if you just go back to bend table, you can use the bend table that already has preset, right? So this bend table is already preset by the company standard. You can create bend tables. You can also down here pre-select if you want to have some auto relief. So if you want to create auto relief, you have this already preset. But if you work in a company that this does everything pretty much like almost, precise, then you want to probably you can use tear, or you could just use, these are just different holes that it's going to make before it does anything. I like to use tear a lot because it seems like if you work in a very high-end company, it sort of just pulls a metal directly from there. So once you have that all preset here, you confirm that. Now take notice also as to what direction is going to be extruding to. This will start to create your bends. In other words, the bend drawing will tell you if this is going up or down, right? So this is important that you keep track of this, because if you have a setting where you want your plastic, meaning the plastic to be this surface, then you might want to consider as far as how you want to extrude your the next phase of this, your flanges, right? If you keep this pointing down and you want your plastic to protect the outside, which is pretty much nice and smooth, then you want to sort of keep that from moving out. So what we're going to do is we're going to move this down. So we're going to commit to that. Now it's going to create your part. See how it sort of does that little background that you notice that? Well, what that is doing is actually going towards that Excel file. It's reading that Excel file and saying, okay, this is what you want because you have it preset in your Excel file. And those things are preset already. If you go to the tools, you go to options, then you go to document, file locations. Here, you see how it says document templates? Well, here's also is where you can find your bend tables, right? And you can also find whatever sheet metal formats, sheet metal bend lines, sheet metal bend tables. So here is where that bend table is located at. So it's bent somewhere in there, right? So it's in there. So that's where that's located at. So you can actually use this as a way to sort of modify that later on if you needed to do so. Okay, so let's go back to sheet metal tab here. I like to make my own tab for it because some people like to keep it in the feature and they have to have it all over here. I like to just have it on the sheet metal side so you can pretty much have all the tools that you need here. So as you notice now, everything's been sort of activated now. So right now we're going to create an edge flange. Okay, so again, it's important that you follow how you want this thing to be bent, right? If this is going to be where the plastic is being laid out, then you want to protect you want to protect this area. So you want the bend to be done facing down so that all the scratching of the surface of the press brake is going to be on this surface while it's protecting the plastic side, which is going to keep it nice and pretty. So it all depends on how you want to do it. You know, if the box inside is what you want to keep pretty, then you want to sort of have your flanges facing up. So I like to just pick up, and you can just pick anywhere there, and then you just go around, right? And it's going to start creating a flange all the way around, right? Now I want you to take notice that it's showing you a preview of what's going to be happening on the gap distance, right? You notice that, right? So if you have a company that has a very, precise way of some places have where the whole extrusion and the whole sheet metal process is done automatic, even the welding of this. So this will probably be too much of a gap distance here for that type of process. So if you notice here, right, here's where it says gap. You can probably just take that to 0, and it's going to take that really tight. You see how it's closed it up? And that might be a process where you could, if you have it all automatic, then that gap distance right there has already been done. See, it's all been sealed. Now, if you work in a place where they actually weld these things together, actually use the weld technique or basic welding technique, then you probably want to give it a gap, because that welder's going to appreciate that. It's going to really like the fact that you left them enough of a space for him to put his rod in there. But if you have a place where they does automatic and it's laser welded, then take away that gap, right? So here is where you have it has a default radius here, because that comes from that bend table that I showed you earlier. There's a bend table that creates this use default radius. This is being programmed in by that table, which it is because of the standard of the company means that this is the bend radius that we're going to have on that bend. So you can also change that. If you don't want to use that, you can change it. You can just unclick it, and now you can do whatever you want there. But if it's a standard of the company and they're using the bend radius table, then I suggest that you leave that on, right? So that it doesn't create any confusion later on. If you notice that down here, we have the angles of these things, but it can only, if you want to have different angles of different things, then it's better if you just pick, you could do it multiple like this, right? You can see how it's turning into itself. But if that's not what you want, if you wanted one of them to be out and one of them three to be straight, then you have to pick that one individually and then say, no, I want you to be different, right? So you can say 90, right? And then say, okay, okay, edge 1 is this one, edge 2 is that one. That's the one I want to bend out. So you can just delete that one and it takes that one away. And then you can say, okay, this is what I want. This is the distance I want. I want it to be 3.5. And here is where it's important. See these little icons here, right? These are what it tells it that where is it going to be measuring to? Like, what is the distance between this flange and the part itself? Currently, it's going to what is called an imaginary intersection, meaning it's taking the measurement of this flange here from an imaginary intersection, meaning it's taking it from like whatever this here is, this little spot right around there, an imaginary, right? And it's going to tell you it's taking 350 from this imaginary spot up here to 350, but physically it might not be. It could be, but it might not, right? So, but if you want it to be real 350, meaning from here to here to be 350, then you have to change that parameter on this icon here, right? So if you say 350, see how it slowly went up a little bit? If you go back, slowly went down, up, and then this one is the same, almost the same, but this one is more towards where the radius is at. So these parameters are set up for if you want to have it 350 from the bottom of from the top of this radius here all the way to the top. Also, the flange position, right? Do you want it to be on that at the edge of that box? So that means that whatever distance, if this box needs to be 16, right? We said 16 and you want it to be 16. Right now it won't be 16. It'll be a little bit plus that little bend radius right in there and then that on the flange. So that'll probably be like, 16.10 or something like that. But if you need it to be 16, exactly 16, then you need to take one of these and push it in. See that? You see how that pushed that in? So now it's taking it, it's putting this face here to the edge of that, which then means that it's going to be, that box is going to be 16 right on the money. Okay, so once you have that, you can confirm it. And then something went wrong there, but I think it's because it picked a wrong edge. Wanting thickness bend scales on top of pencil. Okay. So if you notice that error, try it again. That was a weird error. It's not supposed to happen. So, oh, it's happening because again, it doesn't have the gap distance, right? It doesn't have that gap distance. So if you want to fix that, you're going to have to give it back give it a gap distance of 0.001, something like that. Okay. Let's try that again. Let's see. Okay. Duct of the vent allows the duct to be evaluated by the K factor instead. Okay. So let's go to okay, perfect. Sometimes this thing is very picky about what it wants to do. So you got to work around it. Let's take that gap out again. Let's say the 0. There was that K factor. There was, oh, no, I guess it was needed a little gap. But you have to give it that gap, I guess. Okay, so the program is sort of warning you and gives you, because it needs to unfold this, right? So right now, if it can't unfold it, it's going to give you that error. So if you say to flatten this out, it's going to flatten it out. It's going to create the flat sketch for you. But if it's too tight, then it won't be able to unflatten itself out. So it's giving you that error, but you could overwrite that a little bit. You can say, you know, I really don't, you know, keep playing with it until you get just about right. All right. Still giving it that gap. See? Let's try that again. Let's give it 0.001 and see what happens. Okay, that's very close. That's as close as you're probably going to get as far as you flatten it. You know, you come up here and you say unfold or fold or flatten. That's going to be more like if the part's made by some other program. So you have this icon up here, this icon here, you just confirm that and you can just go back to being the way it was. Okay, so now you have over here, if you notice over here, you have a flattened pattern. There, you can bring that up to the drawing itself if you need it. So this is pretty much, you can, let's do another edge flange here so we can see what I'm talking about. You can have one set up one way, and you can then set this up at a different angle. And you can just play around with this until you got it where you want it. And say, yeah, this is what I want. And it gives you another error. And I think it's because of the way that's preset at 2. Let's say, yeah, let's confirm that. Okay. This is a lot of errors on this. Okay. Maybe let's see if we can. There's a lot of stuff sometimes that this program does, and you like, oh my God, why is it doing that? And you got to keep playing around with it until you find out exactly what's going on. You know, if it could be the way it bends. See, now what was happening was, let me show you what's going on here, so you get that if you ever get that error. This position here was making it so that it was interfering with the way it could flatten itself out, right? So if you try to flatten this out, what's going to happen is it just can't, right? It's just, it doesn't quite work out because it doesn't know how to solve this mathematical problem here. There's something wrong with this. So sometimes you have to sort of say, okay, maybe it's because of this, you know, and then you see it come push out and you're like, maybe that'll flatten it out. So you keep playing with that until it flattens it out. And it won't flatten it out until you solve the problem. So you gotta keep plugging away. I always tell people when you're doing with sheet metal or anything in Solidworks, if it doesn't work one way, it's because you're doing something wrong. If you keep plugging away at it, you'll get exactly what you need. And now you're not gonna be an expert at this every single time. I mean, I've been doing this since 2006. And again, I've always run into some problems because you can't remember all the rules. There's so many rules. So it's better if you know it can do it. You just got to keep plugging away at the parameters, right? You have to figure it out. Okay, is it this? Is it that? Okay, that's the problem. And then you're almost going to get it instinctively. After a while, you're going to figure this out. And if you do a lot of sheet metal, this will be a secondary thing. You not have to worry about this. So here's one of the most important rules of this that I wanted to go by. So and I get this error. I've seen people do this a lot. So I want to sort of help you not make that same mistake. This here is a flattened view, right? And I have seen people come up here and say, well, I need to make an extrusion cut here. And then I make it here and say, yeah, that's what I want. I want to extrude cut there. And I know that that's where I wanted at. perfect, and they go about their business, right? And they want to be able to see that after this thing has been unflattened, right? The problem is it doesn't show up. And you're like, wait a minute, I created this screw, it cut a screw there, and I know exactly what it needed to be. Well, when this part is flattened out, right? When this part is flattened out in your sheet metal thing, this is one entity. Like it's the same part as the top one, right? As the folded one. But this here is just like try to imagine it as a snapshot of it. It's an imaginary snapshot of that particular unfolding. It has value, but it doesn't have the value. It has value to be extruded. Like you can right click this and say, save this face, export face, so that you can laser it out, right? It creates a DFX and you can laser that out and have it lasered for you. And then you can go ahead and do the unfolding process. But it doesn't retain none of the, you can't put something flat on the flat surface. And then when you unbend it, you expect it to be on that 3D portion. So I tell people, don't do that, right? Just don't do it. If you need something on the flat, do it on the 3D. So for instance, if you need it here, then you say, okay, I need that extruded cut here. I need it sort of here. Yeah, I need it there. Perfect. Now, if you flatten that out, it's going to be where you want it to be. You see, that's the purpose of this. Now, this piece here, this sketch here is not, you can't edit it in the flat. I see how it's sort of floating up there. That's because that's where that belongs. That's where it belongs in that world, right? Not on the flattened world. So keep that in mind when you're making your design and in sheet metal, and when you want to create something, modify something, make sure that it's being done at this level, not at the other level, right? Because it won't transfer back to the 3D. So I hope that this is the initial one. I'm probably going to be touching more on these later on. I'm going to be going through the whole process here and get this whole thing sorted out. I'll be touching all of these and getting a little bit demonstration of how all of these work. I hope you stay tuned and please subscribe and hit like or put a comment if you feel like you need to ask me a question. I'll be more than happy to help you with any SolidWorks needs. And that's pretty much it for today. I'm going to be trying to create more videos. I've been out for a couple of weeks, but I'm very happy to be back. And I hope that you enjoyed this video, and let me know if you in the comments if you need to see more. Thank you.